All right, welcome everyone. So in this video, we are going to take a look at a couple of concrete examples, and we are going to see how we can apply the algorithm we just talked about for finding the inverse of a matrix. So here in question 1, I want to find the inverse of this 2 by 2 matrix. The top row is 3, 6, and row 2 has entries 1, 2. So let's follow our process with the algorithm. And the algorithm says, let's set up the augmented matrix where I have matrix A on the left, and then on the right, we augment the identity, the 2 by 2 identity matrix. And I have a little vertical bar separating the two. And now I want to try and put matrix A into reduced row echelon form. So I can do an interchange of the first two rows so that I have a pivot of 1 in the top row. And then I can do a replacement, replace row 2 with minus 3 times row 1 plus row 2. That gives us a 0 here. It also gives us a 0 in the second column, in second row. Here's what we get when we apply that same operation onto the augmented identity matrix. And here, this matrix A is not equivalent to the identity matrix. It's not row equivalent to the identity matrix because its second row has no pivot. So from this, we can see that actually A is not invertible. It does not have an inverse. So not every single square matrix is invertible. And this is what it looks like when we apply this algorithm to a matrix that doesn't have an inverse. So here we would just say A is not invertible. Let's take a look at question number 2, applying this same algorithm. So in question 2, we have another 2 by 2 matrix that we want to find the inverse of. In this case, the matrix has a top row of minus 2, 4, and the second row is minus 3, 1. So to find the inverse of this matrix, we will set up the augmented matrix first. And so for the augmented matrix, we have minus 2, 4, minus 3, 1, and we have a little vertical line, and then we put the 2 by 2 identity matrix to the right of that matrix. And let me first scale row 1 by a factor of minus 1/2, so that we make this first pivot 1. So we scale everything in this row by minus 1/2. Now I'm going to eliminate the entry below the first pivot by replacing row 2 with 3 times row 1 plus row 2. So that gives us a 0 here. The 3 times minus 2 gives us a minus 6 plus 1 for minus 5. We have a minus 3/2 that we add down here. Then let's take this second pivot and let's scale it by minus 1/5. So we're going to scale row 2 by minus 1/5 so that now we've got 2 pivots, both of which are equal to 1. And to put it into reduced row echelon form, what we'd like to do next is eliminate the entry above this pivot. So we're going to replace row 1 with 2 times row 2 plus row 1. So row 2 has not changed. And for row 1, on the other side, we would have 2 times this, which would give me 6/10 minus 1/2 gives us 1/10 left over. And then we have the minus 1/5 times 2, and we add that to the top, so that would give me minus 2/5 up top. And now we've got matrix A has been written in identity form over here, so what's on the other side has to be the inverse. So the inverse of A is a 2 by 2 matrix where the top row is 1/10 minus 2/5, and the second row is 3/10 minus 1/5. And as always, I would highly encourage you to check your answers, and in particular, see what happens if I take A multiplied on the right by A inverse, do we get the identity? And when I take A and multiply on the left by A inverse, do we also get the 2 by 2 identity matrix back? And you can verify that you do in this case. So essentially what we're seeing here is that this matrix that we started out with is a composition of 4 different elementary row operations, And we are applying the opposite of these operations in the opposite order in order to obtain the inverse of a